Great, so hopefully you've got, I know a lot of you already sent me your solutions. If not, right now you should have, by the time you see this video, have sent me a solution. We're thinking about Mr. House's new guitar pick company, and we're thinking about how many large and small boxes can fit inside that shipping container. And what we're going to do first is we're going to visualize this problem. Now, when we visualize it, in this particular instance, it's not the way we're going to always be able to do, but I think if you can do it, it's a really useful thing with this problem, which is actually to make the boxes. What we're going to do is we're going to make a small box, we're going to make a large box, and then we're going to show the shipping container using some tape. Inch by 2 inch cube, which we can now use to look at how many of the small cubes we're going to get. And so after a little bit of difficulty in our construction, we also have a 4 inch by 4 inch by 4 inch cube. So let's have a look at our 2 cubes right there. Though, even though this seems like it should be a half, right? 2 inch by 2 inch by 2 inch. When you actually look at it, each side is a half. So it looks like it should be a half, 2 inch by 2 inch by 2 inch, of something that is 4 inch by 4 inch by 4 inch. If you actually think about it, I can actually fit 1, 2, 3, 4 here, which would and then that would still only give me half of this face here. So I'm actually going to be able to fit 8 of these cubes in here. So the last part, if we're going to visualize this problem, right, is let's have a look at how big a 6 foot by 4 foot by 4 foot box is. So, move everything off the floor, let's get going. So before we even worry about any numbers or math, we'll just look at how small these boxes are in relation to this huge container that we now have. Once we've shown what these numbers actually mean, I think that makes a big difference. I'm going to fit a lot of these things in here. So I need to be really keeping that in mind as I play around with numbers. So now let's do some numbers, because we've done mathematical thinking. I think the first thing to say is that it might say that now let's do the math. Well, by making that box, we were doing mathematical thinking. We were thinking about what numbers we actually have here. But let's do the numbers part of the math. Let's not forget that this right here is 2 inches by 2 inches by 2 inches. And as I've just seen, the big thing about this problem is that I then have feet. So what is the relationship between inches and feet? 12 inches in 1 foot. So if I have something that in this case is 2 inches, that is 1/6 of a foot. My cube is 1/6 of a foot. So for that small box, each of my dimension is 1/6 of a foot. 1 times 1 times 1 is 1. 6 times 6 is 36. 36 times 6 is 216. So that means that each box is 1/216th of a foot cubed. In other words, I can fit 216 of those boxes in 1 cubic foot. At this point, what I can go ahead and do is do 4 times 6 times 4. 4 times 6 is 24. 24 times 6 is, 24 times 4 is 96 feet cubed. So I have 96 cubic feet. For each one of those, I'm going to be able to fit 216 of the boxes of this size. I'm going to be able to fit 216 of those into each one of these 96 feet. So my last step would be to do 96 times 216. Moving on to my other size, my bigger size, each one of them is 4 inches, which is 1/3 of a foot. 1/3 times 1/3 times 1/3 is 1/27. And remember, I know that I have a box that is 90 square cubed feet. So for each one of these, I can fit 27 of this box in. So I'm going to do 96 times 27, and that will tell me how many of those boxes I can fit in. Another way to think about this is that 12 inches equals 1 foot. So therefore, if I have a side that is 4 feet, it's 4 times 12, it's 48 inches. I can convert all of the length of the sides of the shipping container into inches. So in this method, what I do is I do 48 times 72 times 48, which gives me the volume in inches of that larger container. And when I do that, I end up with an answer which is 165,888. Now what I do is I take, for example, this box and I say that it's 2 inches by 2 inches by 2 inches is 8. And I'm going to divide this big number by the 8 in order to find out how many of these cubes I can fit into that big number. So instead of thinking about each cubic foot and then multiplying to get our answers, here what we're doing, we're thinking about that big shipping container as inches and dividing by this. And then what we would do once we found the answer is that we'd think this other box, I'd say 4 times 4 is 16. 16 times 4 is 64. So therefore, I would divide this big number by 64 to find out how many of those boxes I can fit. None of those are my favourite way to think about this problem. My favourite way to think about this problem was given to me by a student a couple of years ago. And they reasoned that 1 foot is 6 of these boxes because the side is 1/6, right? 2 inches is 2/12 or 1/6. So I can count each side in boxes. So the side that is 4 foot long will be able to have 24 boxes because 6 times 4 is 24. Meanwhile, the other side is 6 feet long, so it is 36 of these smaller boxes long. And then I repeat for the height. Now I don't need to do any conversions or I've converted it into boxes instead of feet or converting to inches. But I'm not going to need to do anything other than find the volume in boxes. So I'm just going to do 24 times 36 times 24 to find my final answer. And whichever of the 3 methods that you have done, you should end up with the same answer. For our larger box, well, that's 4 inches in each diameter, so 1 foot is 3 boxes. So I can think of that side that is 4 feet long will have 12 boxes. Side that is 6 feet long will be equivalent to 18 boxes. And then repeating 12 boxes again. And because I've measured already in boxes, I'm going to do 12 times 18 times 12 to get my answer. All of which leads us to this, our solution. We will fit 20,736 small boxes inside the shipping container and 2,592 large boxes. Alright, so there you go, that's the solution. Hopefully you got it right. Even if you didn't get it right, hopefully this has really kicked in your mind some really important things about volume. One thing to remember is that conversions are really important, right? Conversions in 3 dimensions is that there's a multiplication effect in the relationship between the sides. Another thing that's really important to think about with this is a practical context for some of this stuff, which may seem esoteric or not important with volume, but there are ways that you can use volume to think about actual everyday problems. We'll have another challenge problem upon Friday. Have a great rest of your week, and we will see you around.